It's one of the issues we've been dealing with lately, actually, a lot of applications. It's definitely a good idea to not neglect this area, which could create some environmental and other issues within the plant. Today, we're going to focus on our concrete rebuild products, composites, our chemical resistant linings, and then also some grout and precise alignment chalking materials. So going into concrete rebuild, which is actually every time you think about Belzona, you mainly think metal rebuild, pipe wraps. Concrete doesn't really come to mind for a lot of people with Belzona. So we have actually a wide variety of concrete rebuild materials. You're looking at the products right here. So the way they work is it's a epoxy resin mixed with a aggregate. You can see this bag on the top right here. So the aggregate will add some compressive strength and some mechanical strength, and then the epoxy resin makes it a chemical resistant and non-porous system. So the good thing about preparing concrete with these materials is you don't have a lot of the same issues that you would have with concrete once you're using this to rebuild it. So they all have their purpose. The top three right here are similar, kind of flat level, but we have our 4141, which I'll get into later. That's used for a vertical build situation. 4141 FR, fire resistant, is used if you need some fire resistance. And then 4181 is a highly chemical and heat resistant system. So every time there's a scenario, we're going to pick the right product. Going into the characteristics, when you look at our epoxy resins, you're looking at compressive strength above 10,000 PSI. So we're going to outperform your typical concrete in compressive strength, compressive modulus, mechanical properties. Another good thing is we're going to use our primer. I think, so the slide underneath here has the adhesion numbers. We use a primer to achieve maximum adhesion. When we do our adhesion testing, we actually pull the concrete out. So what that says is our adhesion is actually greater than the cohesive strength of the concrete. So we're going to stick better to concrete than concrete is cohesively bonded to itself. So typically, the applications are going to be you have concrete that's been corroded away or worn away, and we're just going to rebuild it. But we also have some other applications such as anchor bolts. We can even use these materials on steel. We can, build pump bases out of them, and I have some examples for you guys. So this is your typical scenario: concrete eaten away all the way to the rebar. And here we used a former, and we used our Belzona 4111, which is usually used for horizontal rebuild, or if you're using a former, you can use it. The good thing about this material is you can create whatever consistency you want. So you can add less aggregate or more aggregate to make it a different consistency, to make it easier to pour. So you can see they poured it in, let it cure. Normally full cure in 24 hours. This is a scenario, kind of a proactive approach. They had a tank sitting on some concrete supports here, and they were having some crevice corrosion right at the tank support. So, it's a minor issue at the time, but if you let this gather up over the years, you can have some through wall defects and some bad corrosion. It's kind of a tough area to deal with. So what they did was they used our concrete rebuild product to rebuild the edge of the concrete and also create kind of a chamfer or bevel from the tank down to the concrete. So like I said earlier, it can stick to steel, it can stick to concrete. And then they even applied a waterproofing membrane over the top to give it a little bit more extra water protection. And this is kind of another typical application: a tank pedestal, really cracked and corroded, cracked under stress here. So this is an application where they actually, no power tools were allowed. So they had to chip away all this with a chisel and hammer. And we ended up rebuilding it with our vertical rebuild material because they didn't want to use a former here. So you can actually, without a former, get to this kind of consistency and end product. And then they applied a corrosion resistant epoxy over the top to give it a uniform finish. So a lot of concrete. Why it wasn't showing. Here we go. All right, so this is an application of anchor bolts. So this was on a mining operation, and you saw the concrete base was just totally coming off. So they wanted a new solution that wouldn't, be porous and corrode over time and lose grip. So they used our Belzona 4111 to create anchor bolt scenario. And I'm going a little bit beyond the secondary containment, just kind of showing you the capabilities of some of these products. Obviously, you got some pump bases and other equipment that's going to sit in your secondary containment. So this is the product here. They went for a more soupy mixture, more pourable mixture, so they didn't add the full amount of aggregate. It will still cure and still have the mechanical properties required. So then they stuck in their bolts with a little twist so they can remove the air pockets, and the product should be coming out. And now you see it's not coming out like it was in the beginning. I think I might have skipped over. You can see this is the beginning here. I mean, not good. So, and then this is your end. So going into, so those are some concrete rebuild products. They got a lot of different uses. Next thing I want to talk about was composite repair. We have different types of reinforcement that we can use to rebuild any, sorry, is there a question? We can use any type of composite to rebuild deteriorated concrete that's been cracked, concrete that's lost its strength. So we can actually use our carbon fiber fiberglass super wrap system with a standard to increase beams and wall shear strengthening, and also for concrete confinement. So if your concrete is being compressed and it's actually cracked due to compression, we can wrap it, and that's what this picture on the left is. We can wrap it with a composite to confine it and give it some more compressive strength. So, and this is an example of a concrete that was just corroded. Again, not a secondary containment per se, but just showing you the capabilities. This is offshore. We used our rebuild product to rebuild concrete back to its original profile, and then wrapped it all to give it a little bit more compressive and shear strength with a fiberglass wrap. And then finally, kind of when you think about secondary containment, your important thing is we want to coat our concrete and protect it from any chemicals that might spill into the containment. And as you can see, I have a lot of lines on the left there because we have a lot of different solutions. Anything from concentrated acids to hot acids to more cost-effective solutions for dilute acids or less aggressive chemicals. We also have flexible solutions for crack bridging or expansion joints. And we even have a static dissipative coating. So I'm going to go through a couple of them in several slides and then show some examples. Off the top, whenever you're dealing with secondary containment, for the most part, what I've seen is you're looking at some aggressive chemicals, sulfuric acid, acetic acid, hydrochloric acid. So we do all of our testing as per ISO 2812-1, which is a test where you immerse the coating in these chemicals for a year. For them to have an excellent rating, they have to be untouched after a year. So no defects after 1 year. And then you have a good rating, a moderate rating. So we have different ratings. And it's really important to understand what you guys want out of your secondary containment. Do you want a product that can be fully immersed in that chemical? That gives you the highest safety factor. Or do we need a product that can handle that chemical for 12 weeks? Because if you're washing that chemical out every 2 days, then it really is not exposed to that chemical for a year. But we try to always have that excellent rating just because it will add up over time if it's immersed for a couple of days at a time over the long run. So we're gonna choose the most chemical resistant system that we can for whatever application we need. We also have some really cool flexible coatings, and I want to show you guys a little video here. So short and sweet there, that was 4311 and 4361, which are our high chemically resistant products. 4361 was developed to have a product that has a little flexibility. So it's really useful whenever you have to bridge a crack or if you're going over a control joint. It's rated excellent up to 93% sulfuric acid. The 4311 is rated excellent up to 98% sulfuric acid. Whenever you're trying to make something more flexible, typically you're going to lose some chemical resistance. So to have 4361, which has 16% elongation and can still handle those strong acids, is a very, very high technology system. We also have a more economical version that can handle a little bit less chemicals, 5815. It's going to be a little bit more flexible. That's part of the reason why it can handle less chemicals. And we're using that a lot in scenarios as well. And then we have our elastomers, which can go up to 1,000% elongation. Those are the most flexible we have, and they can be also used in the similar scenarios. And, scenarios we're talking about mostly is going to be bridging cracks. So if you have a crack underneath the coating and it's moving with the expansion and contraction with the concrete, you want to have a more flexible coating so that the coating doesn't crack. If you're doing a pump base and there's a lot of vibration from the pump, something like that, you want to use a more flexible coating. Control joints, you might want to use a more flexible coating. So there's scenarios where you would put these into play within your specification. Expansion joints, we can use some of those elastomers. We probably would not use the 4361 or the 5815. We would go for more flexible solutions such as our elastomers. And we also have some specialized epoxies that are built for expansion joints. And really, they've just gone through a different set of testing. They're a little bit more flexible, but they've also gone through an expansion joint testing protocol. So we have different types that we can use. We can use some specialized for vertical expansion joints, some for horizontal. Some are more chemical resistant than others. We have a polyurethane base and an epoxy base. So we can just mix and match and find the best, most effective solution for a concrete containment area. And then finally, we also have a static dissipative coating, Belzona 5813. So this is a good solution if you have a containment area where if a spark were to happen, you could have an issue. So basically it has a lower surface resistivity. So it can allow kind of a current to flow at a bigger pace than our normal epoxies. So you can look here, the surface resistivity of 5813 is somewhere in the range of 1 to 100 mega ohms, whereas our 5811, which is our kind of the equivalent to 5813, is 4,400 mega ohms. So this is a much more dielectric material, much less conductive. So this allows, if you have it grounded, static dissipation, so you don't build up an electrostatic charge. So any surfaces coated with 5813, you can prevent some sparks, shorts, or sudden discharge. So this is another application that could be used if the scenario needs it. Then finally, some case histories. We have so we do anything from containments that have been there for years to new construction. So this right here is a new construction, 36% HCl at 176 F. So we have a hot acid. So for that reason, Belzona 4181 was chosen as the full system. Now, if you do remember, this was part of the rebuild section, but this coating can also be used to just coat everything. So it's kind of killing two birds in one stone. You're rebuilding and coating at the same time. This is definitely a more durable system than our typical, coatings. It goes on at about an 1/16 to an 1/8 of an inch thick, and it has aggregate in it, so it can really handle a lot of impact and wear over time. And it's also very chemical resistant and heat resistant. So that's your finished application. And it's troweled on. You apply a primer and then you trowel it on. Then this is a pump base. Pump base was deteriorated over time. So we rebuilt the pump base with our rebuild products and then coated the entire pump base and containment area of these pumps with a coating that can handle HCl. Again, this is an HCl area. Sulfuric acid, another typical one we see in the secondary containment. So this was an interesting one because they were also having some drainage issues. They wanted it to drain to one location better. So we could use our concrete rebuild materials not only to rebuild any concrete that was heavily deteriorated, but we also made a little slope that allowed for better drainage. And then once we accomplished that, we coated everything with the chemical resistant 4311 in this case, which is a two coat system. You apply 2 coats, 1 primer, and then 1 coat of 4311, and that's your finished application. And then finally, I wanted to show this one, a xylene containment area. Xylene is going to be a little less aggressive than your sulfuric acid and your acetic and your strong acids. So here you can go with a more economical version, which is our 5811. Still, any coating, so all of our Belzona coatings were really designed for full immersion. So you're using a product that can be immersed in these chemicals for long periods of time. So for secondary containment, it's really a high safety factor and a really reliable solution. So they were having some issues with some coatings that they were used that were more for just an external environmental protection. They were delaminating over time, being exposed to this chemical. So 5811s is rated good against xylene. So it was, for secondary containment, kind of an easy application. And this 7 years later, they were having no issues. Then finally, I just wanted to show some of our grouts and chalking materials. So we have 2 products for this. And also I want to mention that we could use our concrete rebuild products as a grout as well. But we have some specialized systems. So we have our Belzona 7111, which is a chalking material made for precise alignment. It's going to be self-leveling, 30,000 PSI compressive strength in 16 hours, vibration resistant. It's gone through a whole bunch of approvals and acceptances. It's mainly used in the marine industry for precise alignment of equipment on ships. Really can protect your equipment from any misalignment that could affect shafts and other equipment within compressors, motors, pumps. And then we have our 7211. So this can be used with 7111 and also by itself. So the big reason for the addition of 7211 was it provides a low exotherm, so we can really pour this, thick. The 7111, you don't want to pour it too thick. You couldn't do like an 8-inch pour. You can do, 1/2 inch to 1 inch. So if you really have to build it thick, you can start with your 7211 and then finish with your 7111. You can also, if precise alignment isn't exactly required, you can just stick with 7211. It also has some self-leveling to it. 13,000 PSI compressive strength in 24 hours, 100% solid, solvent-free. Finally, one more secondary containment application, this time using our precise alignment. So they had this tank base, tank support that was sitting on the concrete support here. And they were having some issues with the wooden shims rotting over time. So they went ahead and used a former and poured in the Belzona 7111, which you can see here. They poured it in about 1 inch, 2 inches thick, and created a nice ground for this tank to sit on here. And all done in place. So thanks for your time. Thanks for joining in. Like I said, we do this